Okay. So this booklet, I made this a couple of years ago and I've been adding to it. This is a collection of questions that are explicitly E or Lin questions. Okay? So if that's an area that you need to sort of focus on a bit, this is a good booklet for you. So what I did is I went through basically all the exams all the way back to 2002, and any questions that had E or Lin in there that were relevant, I've ripped them out and put them in this booklet. You'll find the solutions to it on the Google Drive in a folder called Extra Resources. And so I've got a couple of booklets similar to this. So this one today, Natural Logarithms and Exponentials, maybe put a title at the top. And the one I'll give out on Friday is about statistics. Okay, so that one's pretty thick and dense, both binomial and normal. The other two booklets I've already given you. Logarithms and exponentials. The other two booklets, one was the Conjecture Booklet. Okay, if anyone wants anything printed, let me know, I'll do it for you. So there's the Conjecture Booklet, and the other one was the Graphing Booklet, okay, about those relationships between f of x, f dash of x, and f double dash of x. Okay, so there's a booklet focusing on those questions, because you can almost guarantee there'll be one of those. So yeah, there's sort of 4 of these things going, and I might try to put one together for trig questions as well, because that's sort of new to the course, but does seem to be an area of focus as well. They've got sort of, yeah. So we might just do maybe 2 of these together. Okay, so this question 8 here, I think this is from the 2004 exam, but still relevant skills. So we've got, and this is a nice 5-mark question. I think it's a nice easy 5-mark question as well. We've got, well, that's horrendous. The integral from 0 to a of 2e to the 2x is equal to 3. Find the exact value of a and write it in the form ln k, where k is an integer. So we need to perform this integral, e to the 2x. So e to the 2x is 1 on 2 e to the 2x. From 0 to a is 3. And so this becomes, yeah, e to the 2x from 0 to a is 3. We'll plug a in and we'll plug 0 in. Sorry. So, Ruby, I'll answer your question first.
It's going to be a really hard question. But, so could you move the 2 out the front and not include it in the thing?
Yeah, you could. I'm going to leave it there because it cancels. 2 times a half cancels. Yep.
Why is it half?
So the integral of e to the kx is 1 on k e to the kx plus c. So that's the rule. Okay, so other than those 2 questions, all okay? So let's keep going. We'll have e to the 2a take 1 is 3. We'll get e to the 2a is 4. We will lid both sides. And we'll have 2a is ln of 4. So that means a is half of ln 4. Okay. But it says write your answer as ln k. So that means we don't want a number out the front. So that becomes a power. That's ln 4 to the half. And the square root of 4 is 2. So we might jump through a bit because the one just over the page needs you to use your calculator a little bit, and it's sort of lower and upper rectangles. We might jump through to question 7. This one with these two curves. We'll do then. So question 7 on page 12. Yeah.
Which question are we at? We're on page 12 or something. It's in the middle somewhere. Question 6.
There's 2 page 12s.
Yep. Question 7.
So yeah.
Oh, page 12.
Both of them page 12. Is that pulled from you?
I printed this out again yesterday because what I'd done is I printed it and then written on it new page numbers and the year that it was from. But then when I photocopied it, it came through horrible. So I've just updated it, and I'll put some page numbers at the bottom on the PDF version. That might be a good idea. Okay, so that's number. So question 7 with this graph here.
No.
The up graph and the down graph. Okay.
Go to the middle page. Next one.
Through this one.
Yeah.
Right.
Ruby's there.
She's made it?
She's got there, it's okay.
Okay. So, let's have a go. We've got consider the function from 0 to 4. Point A lies on the graph and point B lies on the graph, f dash of x. Okay, so we've got the graph of f of x and the graph of f dash of x drawn for us. Show that f dash of x is this. Well, f of x is this. It's 1 plus 3 ln x on x squared. Okay, so if we're going to differentiate this, what rule should we use? Quotient rule. Quotient rule, very good.
Would it be negative ln x, negative x ln x? Because you applied a negative to all of it, or just?
Yes. That's what it's supposed to be. Yeah. Thank you. Yeah, good pick up. Okay, part B. The graph has a turning point at A. That is where x is e to the k. Find the exact value of k. So, turning points occur when f dash of x equals 0. And I might emphasise that with a bit of a diagram here. Okay, we've got the two graphs. Okay, so here's the turning point. Okay, f of x, f dash of x. So we have this turning point here, okay, this maximum, and notice how it corresponds with the root on f dash of x. Okay, remember that. Turning points occur when the slope is 0. F dash of x is the slope function. Here is where the slope is 0. Now we need to find that algebraically. So we've got 1 take 6 ln x on x to the 3 equals 0. Now when we have a rational function equals 0, we ignore the denominator. Okay, roots occur when the top is 0. When the bottom is 0, we have a asymptote. Very good. So this is what we're investigating. Okay, and then to answer the question, okay, everyone okay? Part CI. This is good. This is a good one because it's both relationships between f of x and f dash of x, and there's some e and lim that we've done already. So the graph of f dash of x has a turning point at B. Find the x coordinate of point B. Simplest way to do this, all right, look, it's worth 1 mark. Let's graph f dash of x and g solve that point of that minimum point there. So it's 1 take and so the x value we've got is 1.649. I'm going to rub out the first part. Okay. Hence, or otherwise, find the x-coordinate of the non-stationary point of inflection on the graph of f dash of x. Now this is one of the relationships we've spoken about, and I'll emphasise it here. And it's going down like that. Okay, so non-stationary inflection, well, any point of inflection is where it changes from being concave down to concave up. Okay, so we have a point of inflection occurring here somewhere, and point of inflection on f of x corresponds with local max or min on f dash of x, which means they have the same x coordinate. Hence, the hence. Hence or otherwise, find the x coordinate. We've already got it. It's the same x coordinate. These have the same x value. We just need to know what is the y value when x is 1.649. And so to answer this, and we're putting it into the original function. We're asked for f of 1.649, and we'll just plug that in. putting it into the original function. Yep. Because we want the what.
Would it be square two?
2. Thank you. Yep.
Mm.
1.649 squared. 0.92 Therefore, okay, now just in how we should communicate this, we can say point of inflection on f of x corresponds with turning point on f dash of x. Therefore, point of inflection when x is 1.649. And we've found the corresponding y value. So, I might not go through any more unless anyone wants to. You probably, if you want, you can focus on some of these questions, or you can ask me some other questions, or do some stuff. And on Friday, I'll bring in the stats book. Yes.
There's a last question. That's asking about like relating it to both equations, can't just like state the minimum coordinates.
C part double
Y
I.
coordinate corresponding to the other equation.
Yes, right.
Because it's that point, not that point.
That's right, that's right.
That'd be-
Yeah. So it has the same x coordinate, but a different y coordinate.
Yeah.
Ready?
Because I was just thinking,
Uh-huh.
okay,
This is
I can't
finally
just take
back
that
on.
one.
Oh, yeah.
Spare drives.
Okay.
Yeah,
Got it.
just, oh, wait, is that what she?
How long she said she spent on it?
She said she spent.
Yeah.